Hello students, today we are going to see the next topic in second unit, that is Coulombs law. That is related to this Coulombs law is related to your force between the two charges. This Coulombs law refers to interaction between 2 point charges. This Coulombs law refers to interaction between 2 point charges. 2 point charges. What do you mean by 2 point charges? The charges are said to be 2 point charges when the maximum dimension is very small in comparison with any other length. So the point charges are nothing but very small. So Coulomb's law states that the force between 2 point charges separated in free space or vacuum by a distance which is large as compared to their size is proportional to their charges and inversely proportional to the square of the distance. And the force is directed along the length joining the two charges. So this is a direct definition for your Coulomb's law. For example, if I consider a charge at this point is something like Q1 and a charge at this point is something like Q2. For example, if this is a positive charge and it is also a positive charge, then there is if these two charges are separated by a distance d, if there is a two positive charges, there is a repulsion force in this direction, and in this direction there is a repulsion force. If I place one more charge here, that is Q3, that is your negative charge, then there is a attraction force in this direction. So let us consider this is a one charge and this is a one more charge. If these two charges are separated by a distance d, then according to the definition of Coulombs, it is based on the experimental. This Coulombs law is based on the experimental observation made by the Charles Augustin Coulomb. Charles Augustin D. Coulomb in about 1785. What he said the force of attraction or repulsion, any force, the force between the two charges is directly proportional to the multiplication of two charges and inversely proportional to the distance between them. So according to the definition, F is directly proportional to Q1, Q2, and it is inversely proportional to the distance between them. The Coulomb's law, here F is directly proportional to Q1 and Q2 and inversely proportional to D square. Here the force is a vector. So here we can write F as F is equal to, or F is proportional to Q1, Q2 by D square. The proportionality constant is replaced by, that is your K, Q1, Q2 by D square. If a vector is nothing but we should have some length, that is of magnitude and direction. This K into Q1, Q2 by D square gives you the magnitude, and the direction of the force is indicated with some vector, that is unit vector, that is along the length of or along the line of your Q1 to Q2. That is, if this is a point of 1, this is a point of 2. So A12 is nothing but in the direction of your 1 to 2. So F is equal to K into Q1 into Q2, that is your magnitude, and A12 is a unit vector which indicates the force direction. Here Q1 is equal to Q1, Q2 are positive or negative charges. These two are positive or negative charges, and D is distance between them. D is distance between charges, and K is proportionality constant. K is proportionality constant. Here K is equal to proportionality constant, which is equal to 1 by 4 pi epsilon naught. Here K is a proportional constant which is equal to 1 by 4 pi epsilon naught, where epsilon naught is permittivity of free space. Epsilon naught is permittivity of free space. Whose value is given as epsilon naught is equal to 1 by 36 pi into 10 power 9 farad per meter. So epsilon naught is equal to, so better to use this 1 by 36 pi into 10 power 9, which makes you the calculations very easy. So from this we can write F is equal to, that is the force is a vector which is equal to Q1 Q2 by 4 pi epsilon naught d square into your unit vector is A12. This unit vector along the length of direction. So according to the definition of unit vector, the unit vector is obtained as, that is your, from the concept of unit vector concept, the unit vector is equal to R12, that is your R12 by mod of R12. Distance vector, we have considered some distance vector R12 by R mod of R12. So R12 is nothing but your R2 position vector by mod of R12. So here we can write it as a F is equal to Q1 into Q2 by 4 pi epsilon naught. The d square we can, d square is nothing but here R12 also we can replace d with, d is equal to distance. Distance is nothing but your mod of R12. R12 is nothing but your distance vector between them. So d is equal to, we can write R12, that is your R12 mod of R12 whole square into the unit vector can be replaced with R12, that is your distance vector by mod of R12. So this is your Coulombs law. Let us take one numerical on this. Let us take a numerical example. For example, a 2 millicoulomb positive charge positive charge located in vacuum at P1 is equal to 3 minus 2 minus 4 and 5 microcoulomb of negative charge located at P2. The values are 1, minus 4 and 2. So find, what you have to find? Find the vector force on the negative charge. Find the vector force. Find the vector force on negative charge. On negative charge. The second one, what is the magnitude? What is the magnitude? What is the magnitude of the force? Magnitude of the force on the charge at P1. On the charge at P1. It means that here you have to find F, find mod F. Simply you have to find first F and then mod F. Let us draw. So here one point is given. So this is your 2 millicoulomb. 2 millicoulomb, that is located at 3 minus 2 minus 4, and this is 5 microcoulomb. 1 minus 4 and 2. So what you have to find? We have to find the force. For finding the force, so F is equal to Q1 Q2 by 4 pi epsilon naught mod R12 into R12 by mod R12. So how to get mod R12? That is your R12 is equal to R2 minus R1. What is R2? 1 minus 4, 2. So 1 minus 3, that is your minus 2. So minus 2 in the direction of your AX. Minus 4 minus 2, that is your minus 2 in the direction of your AY. 2 minus of minus, that is 6 in the direction of AZ. Here we got, that is your distance vector. This is your distance vector. Then what will be the magnitude of this distance vector? That is your mod of minus 2 whole square plus minus 2 whole square plus 6 whole square. So which is equal to 6.633. So from the definition, so F is equal to Q is 2 into 10 power minus 3, 5 into 10 power minus 6. R12 is by 4 pi epsilon naught mod R12 is, here we got 6.633 whole square into minus 2 AX minus 2 AY plus 6 AZ by 6.633. So by simplifying this total thing, here you are going to get finally F is a vector. F is equal to 0.616 in the direction of AX plus 0.616 in the direction of AY minus 1.848 in the direction of AZ. This is your F for the first problem. For the second one, the magnitude becomes, the magnitude of this the magnitude of vector F is equal to under root of 0.616 whole square plus 0.616 whole square minus 1.848 whole square. So finally here you are going to get 2.043 newtons. So this is a Coulomb force between the two charges. So in the next class we will see the new more topic. Thank you.